Hello everybody, my name is Bohut Deshpande, and I want to start off by saying that this is an optional video. You don't have to watch it if you just want to kind of move on to the CV stuff. But in this video, what I really want to do is just kind of keep filling out this matrix, and so we can kind of see this result. And so the point of this video is to hopefully give you a little bit of more insight, and it'll be cool because we'll actually see why this particular kernel is an edge. And because if you look at our image, this is black here and this is white here, 255. And so when we compute the convolution, we expect to see something that kind of resembles an edge here. So we are going to, I'm just going to do a quick recap of how we did this computation. You just take the pixel value here and you multiply it by the kernel number here, and then you do that and you take the sum for this small window. And so now that and here's the actual computation in longhand. So now that we have, done this, let's keep doing this for the rest of the image. So I can slide it down. I can select this here. Whoops. So what I can do is I can actually still take this window here and slide it, downward. And with that, I also have to slide this. Actually, let me just redo that. Let me just kind of get rid of some of this stuff. But the window, what I can do now is now I'm looking at a different part of the image. And I'm looking at this part, and so now my new anchor point is going to be the center, which is right here. And I want to overlay my values again in purple. So the first row is 1, 2, 1, 0, 0, 0, -1, -2, -1. And so now where is this anchor point? Well, it is in the third row and the second column. So I know that the value that I want to fill out when I compute this operation is going to be right here. It's just one below this. Okay, so now let's actually, let's do a quick recap and compute this. So let me use blue here. And so if you remember how we compute this, right, we take the pixel value here, which is 0, I multiply it by the value that's in the kernel at the same position, 1, plus, then I do 0 times 2 here, plus 0 here times 1, plus this 255 times 0, 255 times 0, plus this again, 255 times 0, right? Because all we're doing is just taking the value here inside of the image, which is the pixel value, and I'm multiplying it by the value of the kernel that I've kind of overlaid on top like a transparency. So we only look at this window, and notice that because we're looking at a window, we're not looking at the whole image because we don't even consider this first row. Then 255 times 0. Move on to the next here, and we have 255 times -1 plus 255 times -2 plus 255 times -1, and I'm just going to give you the answer here. It's actually also going to be -1020. So -1020. And so now, you might be saying, well, wait a minute, now we can't really move this kernel anywhere, and so we just end up with, what, just two values here? And I say, well, that's not really quite the case, because, so as it turns out, I don't want to get too involved in this, but as it turns out, what you can do is, if I want to compute, say, this, if I want to slide it down again, what I can do is I can actually pad my image with this is called extend edge handling. And so at the edge, basically what I'm doing here is I take the value that's closest to this edge and I just kind of extend my image by like 1 or 2 pixels here. So 255, 255. This is kind of the closest number here. 0, whoops, should be over here, and 0, 0, 255, and So it should be 0. So I'm basically just like surrounding my image with a border that's representative of the pixels here. So I just kind of extend out in this direction. That actually looks kind of bad. So 0. Okay. So I kind of extend outward in this direction. And now that I have this, now I can slide my window over to the left and to the right and whatnot. But let me actually just complete this operation so that we can see what our resulting image is going to look like. So let me get rid of this and whoops, that's not it. So let me actually just fill in the rest of this image here. Okay, so I went ahead and filled in the rest of this image so that you don't have to keep computing this. But now we see that this really is an edge detection kernel, because if you notice, there's an edge right here, and it seems that we've detected it, because now, you know, everywhere on the top and bottom rows, there's zeros, but here, you see that we have this really large negative value, and actually, when we're dealing with, in the specific case of edge handling, what we would do, or edge detection, I should say, what we would do is actually take the absolute value of that and drop the minus sign, and then bound it above to 255. So then we get this kind of white band here, and that's telling us that, hey, there's an edge here. So we can see that convolution actually is really great for not only applying effects, but also doing things like edge detection. And then, you know, our resulting image here, or our original image has an edge here. Our resulting image will have, you know, regions that are really positive or really negative that tell us that, you know, there's something interesting happening here based on what this kernel is. So anyway, that is a little bit more detail into convolution. And, you know, I just don't want to get like really far into it, but if you have any questions about this stuff, please post a comment or a question, and I'll get back to you, you know, as soon as I can. I really want you guys to understand this stuff, because it's pretty important that you understand, you know, at least on an intuitive level, what convolution is, so that, you know, you don't make any mistakes when you're trying to apply it using OpenCV. So that's where I'm going to stop for this video, but I'm just going to, you know, I just want to mention that with convolution here, what we're trying to do here is we're taking our window, we're kind of sliding it around, and these blue values just mean that we're extending the edge of our image so that we can actually fill out this image. So that the dimension of this image, this resulting image, is the same as our input image. We kind of pad the edges a little bit so that we can kind of get these corner pixels here. And, you know, I've shown you here that when you actually compute the full result for the entire result, then you get kind of this region here that's telling us that, hey, you know, there's something interesting happening here based on the kernel. Because it's an edge detection kernel, this means that, hey, there's something interesting happening here. It's an edge. It's probably an edge. And so that is, you know, how convolution works. And I hopefully you have a little bit better understanding of convolution. So now that we're done with this, in the next video we're actually going to see how we can do this in OpenCV.